Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2017, Paper 2, Higher Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. So this is GCSE Mathematics Higher Tier Paper 2 from AQA. It's the June 2017 paper. Before we get going, just a quick shout out to Gershon Gill and Sana Khan who requested this walkthrough. Good luck guys in your exams on Thursday, I hope it goes well for you. Let's get started on question 1. Circle the decimal that is closest in value to 39 over 800. Now I'm just going to type in 39 divided by 800 into the calculator and get it to display that as a decimal, and I can see it's 0.04875. 0.04875. So which one is nearer? So if I've got 0.048 and 0.049, it's going to be between those two, isn't it? And it's definitely more up towards this end, 4875. So I'm going to be rounding up to 0.049. Question 2. Circle the area that is equal to 36 millimeters squared. Now all the answers are in centimeters squared. Now if I've got millimeters squared, then I'm going to have 10 millimeters for every 1 centimeter, aren't I, in both directions. So 10 times 10 means I'm going to have 100 millimeters squared for every 1 centimeter squared. So 36 millimeters squared, I'm going to have to divide by 100. So 36 divided by 100 is going to be 0.36. Question 3. A is 212 and B has the coordinates 8, 2. Circle the midpoint of AB. Now there is a formula for finding midpoint. If this is our first point and it has coordinates x1, y1, and this is our second point and it has coordinates x2, y2, then you can remember the midpoint with the equation x1 plus x2 over 2, comma, y1 plus y2 over 2. That's if you like memorizing formula and using it. Otherwise, what you're doing basically is you're averaging out the 2 coordinates, aren't you? So you're taking the 2 x coordinates, 2 and 8, you add them together and divide by 2. 2 plus 8 is 10, divided by 2 is 5. So one of our coordinates is going to be 5. And the other one is going to be the average of 12 and 2. 12 plus 2 is 14, divided by 2 is 7. So the midpoint M is going to be 5, 7. It's that one there. Question 4. Here is a sequence: 90, 82, 74, 66, 58. It seems to be going down in equal jumps, doesn't it? It seems to be linear. Distance between there and there is -8. Between there and there is -8. And from there to there is -8. And from there to there is -8. Okay, so it's a linear sequence and it's going down in 8ths. That means it's going to have something to do with minus 8n. So it is not that one and that one and that one. Must be that one there. Now, if they did have some with minus 8n, I'd need to go on and evaluate this one here. But I don't really need to. That's enough for now. Let's move on. Question 5. A code has 4 digits. Each digit is a number from 0 to 9. Digits may be repeated, and the code starts at 5, 4, 1, and there's another digit we don't yet know. Question 5a says, Amy knows that the last digit is odd, but not a 7. She chooses a different odd number at random. What is the probability that she chooses the correct number? Okay, well, we know that probability is equal to successful outcomes over total outcomes. Now in this case, she knows that the last digit is a odd number. The odd numbers are 1, 3, 5, 7, 9, but she already knows it's not a 7, so she's not going to randomly pick 7. She's going to randomly pick from 1, 3, 5, and 9. So she's got 4 possible outcomes, only one of which is going to unlock the door. So her probability of success is 1 out of 4. 1/4. Okay, the 4-digit code is changed to be an even number. The first digit is 3. How many possible codes are there? So we're going to have 3 something, something, something. Now when you're doing a number of ways of counting things like this, it's always good to start with the one that you have restrictions on. So you've got a free choice for your middle 2 numbers, but the last number there is restricted. This one has to be an even number. So you've only got the choices of 0, 2, 4, 6, and 8 for this one. We know what the first number is, so we've got 1, 2, 3, 4, 5 choices for the first digit. Now for the other 2 digits, we have 10 choices. We've got the numbers from 0 to 9. There's no other restrictions on those. So that's going to be 10 for the second number and 10 for the third number. Giving me a total number of possibilities of 5 times 10 times 10, which is 500. So my answer is 500. Question 6a. Complete the table of values for y equals x squared minus x minus 2. So they've given you some of the values and they want you to find some more. Now it's usually a good idea to start with a positive end because that's a little bit easier to work out. And you might want to just double check your understanding by picking firstly a pair of values that you do know both of, just to make sure you understand what it is you're meant to be doing. So if I did input 3 into this function, I would get 3 squared minus 3 minus 2. 3 squared is 9, take away 2 is 6, take away 2 is 4. Yeah, so that's right. Okay, so that is what I'm going to be doing for each of these questions. So then if I put 2 squared in and I take away 2 and then another 2, 2 squared is 4, take away 2 is 0. Then I've got minus 2, minus 2. Can you see it's repeating itself? So that's probably the point where it turns around and starts going up. So I'm already thinking this is 0 and 4 here, but I'm just going to double check. So put minus 1 in, minus 1 squared minus negative 1 minus 2. Negative 1 squared is positive 1. Take away negative 1 is positive 1. So that's 1 plus 1. Take away 2 is 0. So yeah, that is 0. And then for minus 2, minus 2 squared minus negative 2 minus 2. Negative 2 squared is positive 4. Minus negative 2 is plus 2. So that gives me 6. Take away 2 is 4. Okay, so it is what I thought it was going to be. Right, so draw the graph of y equals x squared minus x minus 2 for the values of x from minus 2 to 3. So basically we just need to plot those points on. Minus 2, 4. Minus 2, 4 is up here. What's next? Minus 1, 0. Minus 1, 0. 0 minus 2. 0 minus 2. 1 minus 2. 2, 0. And 3, 4. Okay. Now this was a quadratic equation, so we were expecting a parabola, and that is what we've got. So I'm feeling pretty confident here that we've got it right. The last part is to draw a continuous curve passing through each of your points. You don't have to be Leonardo da Vinci, but try and get it to be as smooth as possible. What you don't want to be doing is put in like 2 marks on your paper. That will get marked down. Okay, and make sure you're using a reasonably sharp pencil. And make sure you go through each of the points. I'm a bit off on that one actually. It's good to go through the center of each one. Okay, 6C says write down the x-coordinate of the turning point of the graph. Now my turning point is this point here, isn't it? That's where the graph stops going down and starts going up again. Now we only want the x-coordinate, so just reading up to the line, I can see that that's going to be at a half. So the x-coordinate is a half. Interestingly, they don't want the y-coordinate here. Okay, done. Question 7. Use trigonometry to work out the length x. I tend to remember ratios using the mnemonic SOHCAHTOA. Maybe you've got a different way. Maybe you can share it in the comments if you do. Right, so let's label up the sides. Here's my angle. This is the longest side, so that must be the hypotenuse. X is opposite my marked angle, and the other side is adjacent. Now, which ones am I using? I'm using the hypotenuse and the opposite, so the ratio I'm going to be using is sine. Okay, so the sine of my angle, sine theta, is equal to opposite over hypotenuse, which in this case, my sine 72 is going to be my x over 8. Rearranging for x equals, what we're going to do is move that 8 up there. So x is equal to 8 sine 72. Reaching for the calculator. Sine 72. Make sure your calculator is in degree mode. That could be a terrible mistake otherwise. Sine 72 times 8 is 7.608. I'm going to round that off to 3 significant figures. Does it tell me to do that? Nope. If it doesn't say, then 3 significant figures is usually a good one to go for. So I'm going to round that off to 7.61. Question 8. Lily goes on a car journey. For the first 30 minutes of her journey, the average speed is 40 miles per hour. She then stops for 15 minutes, and she then completes the journey at an average speed of 60 miles per hour. The total journey time is 1 hour. Okay, so let's just quickly sketch, before we draw the graph properly, let's just quickly sketch out what we're expecting. So she's going to start at 0, 0, and she's going to travel for 30 minutes at an average speed of 40 miles an hour. Now, that should be a straight line section then, shouldn't it? Which takes us up to, well, we're going to have to work out what that height is here, aren't we? And then what happens, she's going to be stationary for 15 minutes, and then she's going to continue on her journey at 60 miles an hour. So we're expecting a steeper section of the graph up here that terminates at a time 60. So that one was 15 minutes. So that's at 45, isn't it? Okay, so what do we need to do? We need to work out that height for where she'll be after the first 30 minutes, and we'll also have to work out that height there then, what time, where she's going to be after 60 minutes. Okay, so let's do that then. So for the first 30 minutes, her average speed is 40 miles per hour. So if she can do 40 miles in 1 hour, then in half an hour, she's going to be able to manage half that distance, isn't she? So at a time of 30 minutes, she will have traveled 20 miles. So I'm going to plot 2 points straight away. I'm going to plot 0, 0. And at 30 minutes, she's going to be at a distance of 20 miles. So I'm going to have a point there. She's then going to be stationary for 15 minutes. So I'm going to have a flat line between that point and that point there. And then she's going to be traveling at 60 miles an hour for the next 15 minutes. So if she can do 60 miles an hour, then 15 minutes is a quarter of an hour, so she can go quarter of that distance in 15 minutes. So a quarter of 60, half and half again, is 15. So she's going to do 15 miles in 15 minutes. So if she's at a distance of 20 and she travels for 15 miles, she's going to now be at a distance of 35. So I'm going to plot a point at 60, 35. Okay. So now I just need to join those all up with straight lines. Done. Okay, so my graph looks like that. Write down the average speed for the total journey. Okay, now you remember from your DST triangle that if I want to find speed, then speed is going to be equal to distance traveled divided by time taken. So we know that she traveled for an hour, so that's going to be 1. That's going to make our dividing very easy. So how much distance did she travel then? So she started at 0 and ended up at 35. So she's travelled a total distance of 35 miles in 1 hour, giving her an average speed for the entire journey of 35 miles per hour. Question 9. The table shows some information about some CDs. A CD is chosen at random. The probability that it's rock is 1 out of 20. Work out the probability that it is jazz. Okay, so we've got this table. We've already got some information on it. So the number of CDs for a rock is 2, and the probability of selecting it is 1 out of 20. So what does that tell us? So probability is successful outcomes over total outcomes. So there are 2 rock CDs, so probability is successful outcomes over total outcomes. There are 2 rock CDs, and we know that the probability is 1 over 20. So that means there must have been 40 total outcomes then, so that 2 over 40 can cancel down to 1 over 20. So there must be 40 CDs altogether. Okay, so what is the probability then that it's jazz? Okay, well the next part is slightly algebraic, isn't it? I've got x and 2x plus 5 now, and I know that there are 40 altogether, and we know with probability that probability sums to 1 if you look at all the options, isn't it? It's because of completeness. So this 1/20th plus the other 2 probabilities is going to add up to 1. So we can form a linear equation in x here. We can say that our probability of x over 40 plus 2x plus 5 over 40 is going to be equal to 1 minus probability of getting a rock CD, which we said was 2 out of 40. So 1 subtract 2 out of 40 is 38 out of 40, isn't it? So I've got x over 40 plus 2x plus 5 over 40 is equal to 38 out of 40. Now, just multiplying through everything by 40, I'm going to get rid of those 40s on the bottom. That's going to give me x plus 2x plus 5 is equal to 38. So collecting like terms, 3x is equal to 38 subtract 5. So 3x is 33, making x equal to 11. So what is the probability then of getting jazz? So the probability of jazz then is going to be, well, we're told it's 2x plus 5, aren't we? So 2x plus 5 over 40, where x is 11. 2 11s are 22, plus 5 is 27 over 40. So my answer, 27 over 40. Question 10. The pie chart shows information about voters in an election. You can see that more women than men voted. Almost twice as many women than men. Or was it more than twice as many? 3,360 more women voted than men. So work out the total number of voters. Okay. So let's say that number of men voting was X. Then 3,360 more women voted than men. Then women voting must be X plus 3360. Okay. How does that help us? Right, and then I suppose we can use the angle then to work out the rest. Well, what's this angle here? We've got 360 degrees in a circle, so less 110 gives us an angle for women of 250. So I suppose we could use that as a ratio of women to men, can't we? We can say that the ratio of women to men is 250 to 110, and we know that then that is X to X plus 3360. Okay. So the difference in their angles then is 250 take away 110, isn't it? So 250 take away 110 is 140. I'm still trying to think about how best to do this problem. So 250 minus 110 is equal to 140. And then I suppose then that 140 degrees must be that extra 3,360 people then. Okay, I think we might have got onto it now then. So 140 degrees represents 3,360 people. So I'm going to use a method known as the unitary method, or going via 1. If I divide this by 140, I will then find out how many people represented by 1 degree, and then if I then times that by 360, I'll know how many people are represented by 360 degrees. So let's do that then. So 3360 divide by 140 times by 360 gives me an answer of 8,640. So there are 8,640 voters altogether. Okay, we've got there in the end. Okay, question 11. Write these numbers in descending order. Now, whenever they write anything in bold, it normally means that students tend to miss over it or skip over it. So descending means going down, doesn't it, from biggest to smallest. So I've got 3 numbers, 2 of which are in standard form. So let's write those out long then before we proceed. So 10 to the 3 is the same as 1,000, isn't it? And 9.56 times 1,000, it's going to be 9,560. Oh, 9.56 times 3 to the 10. Ew, what on earth is that? Right, 3 to the power of 10 is 59. Well, that's huge. Times 9.56. That's enormous. 564,508 roughly. So I think it's clear to say that that one is going to be the big one. So that is 9.56 times 3 to the power of 10. And then, which is the next biggest, or the next smallest? It's going to be the 9,563, and the smallest then is 9.56 times 10 to the 3. Notice I put them back into the form that they gave me at when I wrote down the answers. Question 12, we've got a circle theorems question. The blurb at the top says A, B, C, D, E and F are points on the circle, and indeed they are. No other information to add to my diagram. Circle the line that is a diameter to the circle. Okay, now for it to be a diameter, what we want to be able to do is use our circle theorem that involves a diameter. So if I've got a diameter and I subtend an angle in it, then this one here will be a right angle. So I can use that to work out which is going to be the semicircle. So I'm looking for a 90-degree angle. So in this first triangle I've got 5 and 95. So working out the third angle of that one is going to be 180 take away 95 take away 5, so 180 take away 95 and 5, which is 100 taken away from 180, so that one's going to be equal to 80, isn't it? So that's 80 degrees. So that one isn't the diameter. This other triangle here, what's this angle here then? So this one would be 180 minus 80 and 10. 80 plus 10 is 90, and 180 take away 90 is 90. So that's my right angle there, isn't it? So because C is a right angle, that means that AD must be the diameter. So that one. Question 13. To make one cheese sandwich, Gina uses one bread roll and 2 slices of cheese. But whoever makes one cheese sandwich? She's going to buy enough packs to have exactly twice as many cheese slices as bread rolls, and she needs to make more than 100 cheese sandwiches. Gosh, that's a lot of cheese sandwiches. So work out the least amount she can spend. So if she's going to make 100 cheese sandwiches, how many rolls and how many slices of cheese is she going to need? Well, she needs to have at least 100 rolls and 200 cheese slices, but that's not the thing here, is it? It's got to be the same, well, exactly twice as many cheese slices as bread rolls that we need, because she doesn't want to have cheese slices left over and she doesn't want to have bread rolls left over. So let's have a look at the pack sizes. Bread rolls come in packs of 15 and cheese slices come in packs of 20. Now what we want to do is find a way of getting twice as many cheese slices as bread rolls out of multiples of 15 and 20. So let's start with bread rolls. Multiples of 15. We want the multiples of 15 but which are greater than 100, don't we? We want to find one that also then works with the cheese slices. So multiples of 15. So 15, 30, going to get 90, 105. 105 is going to be the first one, isn't it? That's bigger than 100. So that's going to be 105, and then the next one will be 120 and 135 then, won't it? Okay, now if I double those, I'm going to get 210, but that is not a multiple of 20. 240 is a multiple of 20, isn't it? So I think what we're going to do then, and 135 just for completeness is 270, so I couldn't do that one either. So I think we need to go for that one, don't we? So we need to make 120 sandwiches. That's the only way we're going to get it so it works out nicely. So we're going to need 120 bread rolls and we're going to need 240 cheese slices. So need 120 bread rolls. So how many is that then? 15's into 120. Go 8 times. 120 divided by 15 equals 8 packs. We need 8 packs of bread rolls and we need 240 cheese slices. So 240 divided by the pack size of 20 gives me 12 packs of those. So then we can now work out what those costs. 8 times cheese, sorry, 8 times rolls is 8 times, how much was the rolls? £1.88. And I've got 12 times cheese, which is 12 times £2.15. Okay, so we can add those up and then subtotal it, can't we? So 8 times £1.88 is £15.04, and 12 times £2.15 is 25.8. Don't forget this is pounds and pence though, so you've got to write £25.80, and then adding those together then, £15.04 is £40.84. So our answer is she needs to spend £40.84. Yeah, that's the least amount she can spend. Question 14. The graph shows the cost of some taxi journeys. We've got a linear graph here. Cost C on the y-axis and number of miles n on the x-axis. Work out a formula for C in terms of n. Okay, and basically we need to find the equation of this straight line, don't we? So equations are normally of the form y equals mx plus c, where m is the gradient and c is the intercept. Here's the intercept here, look. So that's 2.5. So that's our value of small c, not to be confused with big C. And the gradient then, we can find the gradient by picking 2 points on our line and drawing a little triangle between them. So, and then looking at change in y and change in x, m equals change in y divided by change in x. This is 5.5, isn't it? And down here is 2.5. So the distance between them then is 5.5 subtract 2.5, which is 3. And then going this way, changing x, this value up here is 5 and 0, so 5 subtract 0 is 5. So the gradient then is going to be 3 over 5. Okay, so piecing that all together, our y in this case here is c, so y is the big C. M is our gradient, which is 3/5. X is our n, number of miles, and C, running out of colours, let's see if I can find another highlighter. Oh, pink. C then is our intercept of 2. Okay, so big C equals gradient, which was 3/5 of x, but in this case it's n, plus our y-intercept of 2.5. Okay, so there's my formula for C in terms of n. Do I have to need to use it at all? No, that's it. Question 15. Sammy is trying to work out the exact value of y using Pythagoras Theorem. So I've got 2y on my hypotenuse there and 6 and 8, don't I? So here's her working. 2y squared is equal to 6 squared plus 8 squared, so 2y squared equals 36 plus 64, so 2y squared is 100, y squared is 100 divided by 2, y squared is 50, y is root 50. What error has she made with her working? Well, I spotted the error straight away. I'm sure you did too. If I've got 2y and I square it, that's going to be 2 squared y squared or 4y squared. Not 2y squared as she's got there. So what error did she make in her working? That 2y squared is 2 squared y squared, which is 4y squared, not 2y squared. Okay, so part B says Kai works out that y is equal to 5. Mel says y cannot be 5 because the hypotenuse should be the longest side and the other sides are longer than 5. Is Mel correct? Well, I think Mel is making a mistake here because the hypotenuse is 2y and not y, which makes 2y would make it 10, wouldn't it? Not 5. And 10 would then be the longest side. So, is Mel correct? No, she is not. Give a reason. The hypotenuse is 2y, which would be 10, which would be the longest side. Okay. Question 16. Here is a box plot. Circle the median value. Well, I'm sure you all know what's what on a box plot. This is the lowest. This is the highest value. This is Q1, our lower quartile, and Q3, our upper quartile at the edges of the box, and the line in the middle is Q2, or the median. So our median value then is going to be this number here. There are 5 divisions between 20 and 30, so each division must be worth 2. So counting up from 20, 22, 24, 26, 28. So that is going to be a median value of 28. Question 17. P is a rectangle with length 50 centimeters and width x, and Q is a rectangle with width y centimeters. All that information is already on those diagrams. And we're told that length of Q is 20% more than the length of P, and the area of Q is 10% less than the area of P. Work out the ratio of x to y. Give your answers in its simplest form. Okay, so it looks to me like we're going to have to... what are we going to have to do? We're going to have to form some equations here, I suppose. Let's take this statement here first. The length of Q is 20% more than the length of P, but my length of P is 50, so that's just a numerical problem, isn't it? So I can work that one out. I need to do a percentage increase. So percentages, F, O, M, final, original, multiplier. My final amount is the one I want to find. My original is what I'm starting with, is 50, and my multiplier, now this is a percentage increase, so I start with 100%, I add on 20%, give me a multiplier, well, give me 120%, which is a multiplier of 1.2. Okay, so then my final is going to be original times multiplier, covering up the F, tells me that it's O times M. Okay, which is 50 times 1.2, giving me 50 times 1.2, that's 60, isn't it? So then that tells me that Q must have a length of 60 from there to there. Okay, so one step closer to the answer. It says the area of Q is 10% less than the area of P. Well, the area of Q is 50 times x, which is 50x, and the area of Q is 60y. Okay, and we're told that the area of Q is 10% less than the area of P. So the area of Q is 10% less than the area of P. So the area of Q, which is 60y, is 10% less than the area of P. So 10% less. If you've got 100% and you take away 10%, you've got 90%. So 60y has got to be 90 100ths of the area of P, which is 50x. So let's just cancel those, that 0 with that 0 and that one with that one. So that tells me that 60y equals 9 times 5 is 45x. So we need to take that and rewrite it now as a ratio. Well, we can probably cancel it down a little bit more first because they're both divisible by 5. Well, they're both divisible by 15, aren't they? So that's the same thing as 4y equals 3x. Now it takes a little bit of thought to turn an equation into a ratio. So let's imagine that, well, let's make our ratio of x 1 to something. So if the value of x was 1, what would the value of y be? Then y would be 3/4 of x, or in other words, it would be 3/4. So we get the ratio of 1 to 3/4. So multiplying both sides by a factor of 4, which we can happily do with a ratio, just scale it up. That gives us 4 to 3 as a ratio then. So 4 to 3 is the ratio of x to y. Question 18 is a Venn diagram, always my favourites. A school has 86 teachers, 42 are male and 44 are female. 1/3 of the male teachers have blue eyes and 1/4 of the female teachers have blue eyes. So we're going to put that on a Venn diagram. For A, we're told that the universal set is teachers in the school. M is the male teachers and B is the teachers with blue eyes. We need to complete the diagram. Okay, so where shall we start? I think if we look at this bit here, 42 are male and 1/3 of the male teachers have blue eyes. That means we can work out what the intersection is going to be then, don't we? So we've got 42 male teachers altogether and 1/3 of them have blue eyes. So 42 times 1/3, or 42 divided by 3. 3 goes into 42, is that 14 times? So that means there are going to be 14 male teachers with blue eyes. So that means the intersection between M and B is going to be 14. And now I can start working out the rest. So if there were 42 male teachers altogether, of which 14 had blue eyes, then 42 subtract 14 will be the number of teachers who are male and don't have blue eyes, which is 28. 1/4 of the female teachers have blue eyes. How's that going to help us? Oh, okay, I suppose that tells us the bits that are in the number who are in B and not in M. And we know there are 44 female teachers, and 1/4 of that would be 11. So that is that one there then, isn't it? So 11 teachers have blue eyes and are not male. And now we can work out what's left. We've got 86 teachers altogether. So then 86 minus my 3 other parts, 28 and 14 and 11. So that's 42 plus 11. 53. 86 to subtract 53, which is 33 female teachers with not blue eyes. That's what's going to go there, isn't it? Part B says one teacher who has blue eyes is chosen at random. Work out the probability that the teacher is male. So we want the probability that the teacher is male given that they have blue eyes. In other words, if we know that the teacher is in this group, what is the probability then that they are here? So that's going to be, there are 14 teachers with blue eyes out of a total population of 25 teachers with blue eyes. So that is going to be 14 over 25. Gosh, there's lots of ratio questions here. 19. Rana sells 192 cakes in the ratio of small to medium to large of 7 to 6 to 11. The profit for one medium cake is twice the profit for one small cake. The profit of one large cake is 3 times the profit of one small cake. Her total profit is £532.48. Work out the profit for one small cake. So basically lots of information, and we need to work through it all to get to our solution. Let's start off with the number of cakes and the ratio. Let's start off with this line here. And work out how many of each sort of cake we have. So we want to divide 192 in the ratio of 7 to 6 to 11. So a 7 plus 6 plus 11 tells us there must be 24 shares. Okay, so then we're going to divide our 192 by 24 to work out the value of each share. So 192 divided by 24 gives us an answer of 8. So each share is worth 8. So taking our ratio of 7 to 6 to 11 and scaling up by a factor of 8. 7 eighths are 56, 6 eighths are 48, and 11 eighths are 88. Always a good job here just to double check your working. Add up the 3 numbers, just double check that they add up to 88. Oh, sorry, add up to 192, which they do. So I'm happy with that. So what was what? That was small, medium to large, wasn't it? So it's going to be 56 small cakes, 48 medium cakes, and 88 large cakes. Right, moving on to the profit. The profit from one medium cake is twice as much as the profit of one small cake. And the profit for one large cake is 3 times the profit for one small cake. Okay, so the ratio of their profits then. Let's say the profit from a small cake is P. Then what would the profit from a medium cake be? It would be twice the profit of a small one. So that would be 2p. And the profit for one large cake is 3 times the profit of one small cake. So the ratio of their profits is p to 2p to 3p, where p is the profit on one small cake. Now we know that the total profit is £532.48. Now again, what I'm going to do then is I'm going to divide that by the number of p's then. So I've got 56 small cakes with a profit of p. I've got 48 medium cakes with a profit of 2p. And I've got 88 cakes with a profit of 3p. So how many p's is that altogether then? I'm just going to multiply those and add them up. That's going to give me 56p. 2p times 48 is going to be 96p. And 3 lots of 88, reaching for the calculator, is 264p. So my total profit, well, how many profits is that then? So 56 plus 96 plus 264. So that gives me 416p. And I know the total profit was £532.48. £532.48. So one profit is going to be 532.48 divided by 416. 532.48 divided by 416, which is £1.28. So that means that the profit on one cake was £1, one small cake was £1.28, and obviously then on a medium cake it was twice that, and on a large cake it was 3 times that. But we only needed to work out the profit on a small cake, which we have done. Job done. Question 20. Work out the size of angle X. Now I've got a non-right angle triangle here, so it's going to be, and I've got angles and sides, it's going to be trigonometry, but it's not going to be right angle trigonometry, SOHCAHTOA. It's going to be either the sine rule or the cosine rule I'm going to have to use. Now, do you know how to decide between the two? Sine rule is about opposites. You need opposite pairs, and the cosine rule is about 2 sides and an included angle, or 3 sides looking for 1 angle. So here we've got opposites, haven't we? What I mean is I've got this 125 here and it's opposite that 14, and I've got this x here and it's opposite that 6. Okay, so it's going to be the sine rule. Sine rule is about opposites. So sine, we want to find the x, don't we? We want to find the angles. So we're going to state the sine rule with the angles on the top. Sine A over A equals sine B over B. So sine x over 6 equals sine 125 over 14. Okay? So just need to rearrange that now then. So take that 6 and move it up there. So we get sine x equals sine 125 times 6 over 14. Okay, so it's time to reach for our calculator. 6 sine 125 equals, divide by 14 equals inverse sine answer equals 20.55. Now I normally give angles to 1 decimal place, so that is equal to 20.6 degrees. Right, question 21. Solve 5x squared equals 10x plus 4. So I've got a quadratic equation. Now I'm told to give my answer to 2 decimal places, so this is immediately telling me that this is going to be use of formula rather than factorizing. So let's take our equation 5x squared equals 10x plus 4. Rearrange it to get everything on one side. 5x squared minus 10x minus 4 is equal to 0. So then this is my value of A, this is my value of B, and this is my value of C. So A is 5, B is minus 10, and C is minus 4. Okay, so what is x then when I use the formula? X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now I just need to carefully sub into this. So minus b is minus negative 10, so minus negative 10 plus or minus the square root of negative 10 squared minus 4 lots of a, which is 5, times c, which is minus 4, all over 2 lots of a, which is 2 lots of 5. Okay, so what's that equal to? I'm going to continue down here, otherwise I'm going to run into my answer box. Negative minus 10 is positive 10, plus or minus the square root of minus 10 squared is positive 100. I've got minus times positive times negative, so that minus is going to become a plus. And 4 times 5 is 20, times 4 is 80. So I'm going to get 100 plus 80 over 10. And just tidying that up now, that is root 180 then, isn't it? So 10 plus or minus the root of 180 all divided by 10. Okay, time to reach for the calculator. So 10 plus root 180 equals, divided by 10 equals, that's 2.34. So x equals 2.34. Or if I take away instead 10, subtract the root of 180 equals, divided by 10 equals minus 0.34. So, or x equals negative 0.34. They're my 2 solutions, correct to 2 decimal places. Question 22. A ball is dropped vertically. It falls d meters in t seconds. D is directly proportional to the square of t. The ball drops 45 meters in the first 3 seconds. How far does the ball drop in the next 7 seconds? Okay, so we've got a fairly straightforward proportionality question here. Let's start off with the relationship. We're told that d is directly proportional to the square of t. So d, little fishy, t squared. Okay, so once I've written it down like that, d is proportional to the square of t, I can replace the little fishy with equals k and evaluate what k is. Okay, so I've used this bit of information here already. So that was to give me the relationship. Now, with these proportionality questions, you're always given a pair of values that go together, and the reason you're given that is that you can use it to evaluate your constant. So you're going to sub those two values in, and you're going to use it to find k to complete the equation that links d and t together. Okay, so when, well, what is 45d? That is when d equals 45, t is equal to 3. So 45 equals k times 3 squared. Okay, so 3 squared is 9. 45 divided by 9 is 5. So k is equal to 5. Okay, so now I've found what k is, I can replace it back into my equation here, look, to find the relationship between d and t. So therefore, d is equal to 5t squared. Okay, so that's my complete equation now. Once I've got the complete equation, I can then go on to use it to work out any other value of d given t or t given d. Now what it's asking us to find here is how far does the ball drop in the next 7 seconds. Now notice next is in bold, so again, if you're not careful, you'd have just read 7 and shoved that into the equation, but that is not the case, is it? You've got the first 3 seconds and then the next 7 seconds, giving you a value of t is equal to 3 plus 7. It's 10 seconds. So you're evaluating this at the point t is equal to 10, not 7. So what is d when t is equal to 7? Well, 10's a whole lot easier to square. 10 squared is 100 and times 5 is 500, isn't it? So it's 500 what? 500 meters. Okay, so you think you might be done now. Don't just write down 500 meters in the answer line though, because that would be a terrible, terrible mistake. Now again, there's a bit of a sting in the tail of this one, isn't there? Because the ball drops 45 meters in the first 3 seconds. How far does the ball drop in the next 7 seconds? Now we've evaluated that at time t equals 10, d is equal to 500, but at time t is equal to 3, d was equal to 45. So how far does the ball drop in the next 7 seconds is the difference between those two. So our answer then is going to be the difference of those, isn't it? So 500 subtract 45 is 455 meters, which is my final answer, 455m. Which just goes to show, beware of anything in bold in the question. Just really think around those, because if it's in bold, the examiners are basically flagging up that there's a bit of a sting in the tail. Question 23, and we're on to vectors. Is BCD a straight line? Show your work and to support your answer. Now, if you want to show that 3 points are colinear, which means they lie in a straight line, what you want to do is to find that the vector from one to the other, so let's say that is vector A, then what you want to show is that this one is going to be some multiple of the same vector. Okay, and if you can show that that is the case, then you can say that they're colinear. So what we need to do is to find this vector, and we need to find this vector, and we need to show that one is a multiple of the other. Okay, let's see if we can do that then. So vector B to C, what's that then? Well, we can get from B to C by going up here and down here. We've got to travel along routes that we know. We don't know anything about the direct route, but we know those two, so we can use it to work it out. So B to C is B to A plus A to C, and B to A is 5A minus 2B, and A to C, well, we're going against the arrow here, aren't we? So that's subtract, not plus. So minus 3A plus B. Okay, so then just collecting like terms then, I've got 5A minus 3A, which gives me 2A, and I've got negative 2B subtract B. So negative 2B take away another B is negative 3B. Just take care with minus signs and brackets. So that gives me 2A minus 3B for B to C. Okay, now let's see if we can find C to D. So C to D, we could also find B to D. That's another way of doing it. And again, they would have to be multiples of each other. So C to D is 3A plus, well, let's go from C up to A, and then from A down to D. Okay, so we're going, oh, I've still got my pink highlighter, this way and then this way. Okay, so 3A plus B plus 3A minus 9B. They're both positive, aren't they? So that's equal to 3A plus B plus, what was it? 3A minus 9B. 3A minus 9B. So collecting like terms, 3A and 3A makes 6A, and B and minus 9B makes minus 8B. Okay. Well, are they colinear? Well, I don't think so. Now, if they were, so they're not colinear, are they? So B, C, and D are not colinear. That's the posh way of saying they don't lie in a straight line. As I think I'm going to say that B to C is not equal a multiple of C to D. Okay? Or you could write that down in words if you want, but yeah, it's not a multiple. Cannot be expressed as a multiple of C to D. Question 24. 48 students completed some homework. This histogram shows the information about the times taken. Okay, so we've got frequency density along the side, we've got time in minutes down the bottom. Remember with histograms, it's the area of the bars that are proportional to the frequency and not the height. Okay, so we need to work out the estimate of the interquartile range you must show your work in. Oh, that's an interesting question. The interquartile range. So if you remember, the interquartile range is the distance between the upper quartile and the lower quartile. So what we need to do is we need to work out how much time, well, let me just draw this. Imagine all your data points in a line like this, coming from the lowest value to the highest value. What we need to do is we need to find the person who's at Q1, which is 1/4 of the way through the data, and we need to find the person who's at Q3, which is 3/4 of the way through the data, and then we need to work out the distance between them. That's going to be the interquartile range. Okay, so let's have a think about this. We've got 48 students. So if I've got 48 students, then Q1 is going to be well, what we do is we take 48, we add 1 to it, and we divide by 4 to find where the lower quartile is. So 49 over 4, I'm going to say that's roughly 48 over 4 and just do it like that way. So 48 over 4 would be roughly the 12th person through the data set, and Q3 we get by taking the number of elements in the set, adding 1 and times it by 3/4. So I'm going to say that's roughly, again because it's going to give me a bit of a weird number, I'm going to say that's roughly the 36th person through the data set. Okay, so where is person number 12 and where is person number 36 in this data set? Well, now I said earlier that it was the area of each bar that is proportional to the frequency. So if I take this kind of thin toolbar between 0 and 5 here, the area of this bar is going to be the class width 0 to 5, which is 5, times by the frequency density, which in this case is 1.6. Now 5 times 1.6 gives me 8. So that bar represents 8 people. Okay, so person number 1, 2, 3, 4, 5, 6, 7, 8 are in that bar. Okay, now the next bar stretches from 5 to 15, so it has a class width of 10, and it's got a frequency density of 0.8, that's the height of the bar. So if I times those together, again, that gives me 8. So the next 8 people are in this set. So the first 8, 1 to 8, are in the first bar, and the next 8, which is going to be person number 9 up to person number 16, are going to be in that group there. Okay, so remember we were looking for the 12th person. So our 12th person is going to be somewhere in between that bar. We're going to have to kind of estimate how far along in a minute. Let's just finish doing the areas first. This third bar has a class width of 10 and a height of 1.2. And that tells me that this represents 12 people. And then finally the last bar has got a class width of 20 and a height of 1, so that represents 20 people. Let's double check that adds up to 48, 8, 16, 28, 48, yeah. Right, so like I say, we were looking for the 12th person and the 36th person. So if I've got my first 8 people in here and my next 8 people in here, then it's going to be halfway up that bar, isn't it? So the first 4 on the left, the next 4 on the right. So I'm going to estimate that my median, my lower quartile is going to be halfway along that bar at my 12th person. So that's going to be my Q1. Okay, and then my Q3 is my 36th person. So 8, 16, 26, 28, it's going to be in this big fat bar at the end here. So if that was 28th person and this one then is the 48th person, and I'm looking for the 36th person, how far along that bar is it proportionately? Okay, well the distance between 28 and 36 is a distance of 8, and the distance between 36 and 48 is a distance of 12. Okay, does that help me? So that adds up to 20. So it's going to be 8/20ths along that bar, which cancels down to 4/5. No, 4/10. 4/10 of the way along that bar then, isn't it? Okay, that I can work with. So I'm going to have to estimate what's 4/10 of the way along from here to here. So 5/10, that's pretty obvious, it's there, isn't it? So where's 4/10? If I was going to divide these 20 jumps into 4, it's going to be 8 along, isn't it? So it's going to be 8 little squares. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be here. So my Q3 is there. So we're saying that Q1 is equal to 10 and Q3 is 33. So the interquartile range is just given by Q3 subtract Q1, which is, we now know, is 33 subtract 10, and 33 subtract 10 is 23 minutes. Question 25. The diagram shows a logo. We're told that ABE, this one, is congruent to DCE. DCE. So these two triangles are the same area. Okay, and we're told that BCE is a sector of a circle. Okay, so what do we need to do? Show that the area of the logo is 510 centimeters squared to two significant figures. Okay, so we're going to have to work out the area of one of these triangles. We can use the fact that it's congruent to double it up and then find the other one. Plus we need to work out the area of the sector. Right, do we have all the information we need? Not really. To work out the sector, I'm going to have to work out the radius of that circle. I can easily work out the area of the square. That's going to be of the triangle. That's going to be no problem. I can just use trigonometry to do that. But I'm going to have to then use trigonometry again to find r, so I can work out the radius, and so I can then work out that sector. That's going to be the trickier bit because it's a non-right angle triangle, so I think we're going to be using cosine rule, aren't we? So it's going to be quite long. For 5 marks, that's a lot of work. Okay, let's get busy with it then. So the area of a triangle, area of the triangle is going to be half AB sine C. That's our formula for an area of a triangle using trigonometry, which is our two sides and our included angle. So it's going to be a half A, which is 26, times B, which is 15, plus our included angle sine 38. What's that then? So 0.5 times 26 times 15 times the sine of 38. I make that 128.053. Okay, I'm going to give my final answer to, oh actually I don't need to, it's only two significant figures, let's just round it off then. I'll leave it like that. Okay, so that's the area of one of my triangles. So then my sector, I'm going to need to know r first. So I need to know that radius. Now I was saying earlier about sine rule and cosine rule. Sine rule is about opposites, and the cosine rule is either two sides and an included angle, which has got here, look, two sides and an included angle, or it's having three sides and wanting to find an angle. So I know that this is going to be the cosine rule this time. So can you remember the cosine rule formula? The cosine rule formula says a squared equals b squared plus c squared minus 2bc cos a. Now that's the way around you use it to find a length, which is what we're trying to do here, isn't it? Okay, so in terms of this diagram, our r squared, our a squared, is going to be our two lengths squared, so my 26 and my 15. 26 squared plus 15 squared minus 2 lots of 26 and 15 cos the angle, which was 38. So calculator time. 26 squared is 676. 15 squared, you can all just type this in all in one go if you want as well. Minus 2 times 26 times 15, 780, cos 38. What's that then? 676 plus 225 minus 780 lots of the cosine of 38. I make that 286.3. Remember that's r squared, so r is going to be the root of that. So square root in my answer. I make that 16.92. Always good just to check for sensibleness. Does that look right in that diagram? 16.92, a bit under 17. That looks good. Okay, so now we found r, we can then use it to find the area of that sector then. So our area of our sector is going to be the fraction of the circle that we've got. So the angle is 108, so it's going to be 108 360ths of the area of the circle, which is pi times r squared, which in this case is going to be 108 over 360 times 16.92. I'm running off the side of the page. 16 times 92 squared. So let's type that into the calculator. 108 divided by 360 times by pi times by our last calculated answer squared. So I make that 269.88. Where'd I have to write the answer? Oh, I just need to show it. I'm running out of space though, aren't I? Okay, I can still squeeze it in, I think. So then total area is going to be 2 times the area of the triangle plus the area of the sector, which is 2 times 128.05 plus 26988, which is equal to, I'm going off the bottom of the page here, which is very naughty, shouldn't do that in the exam, so plus 2 lots of 128.05, 525.98. What am I aiming for? Show that the area of the logo is 510 centimeters squared to 2 significant figures. Well, I get 530 to 2 significant figures. Okay, I'm not quite getting the answer that I was meant to here. I make that 520 something, where the answer here says 510. So I'm just going to go through and double check all my work. And I've just realized that I made a mistake here when I read the calculator value. I did put the right thing in the calculator, but for some reason I misread the output, and it should be 120.05 there. Now luckily that doesn't change any of my other answers all the way down to this point here. That one there should be 120.05. So let's just type that in again. 2 times 120.05 plus 269.88. Oh, that's much better. That gives me 509.98, which definitely does round off to 510 to 2 significant figures. Okay, so what's the units? Centimeters squared, isn't it? So we have got there. I just made a bit of a silly mistake here. I misread my calculator value. So that is actually a good thing about these sorts of questions, where you have to show that that a calculation is equal to a particular number, because you can error check whilst you're in the exam, like I just did then. So happy I've got it right now. Let's move on. Question 26a. A sketch of a quadrilateral ABCD is shown, and we're told that ABCD is enlarged, centre B, scale factor 1/3. So you know that an enlargement with a scale factor 1/3 is actually going to shrink my shape rather than grow it or enlarge it. It's going to actually get smaller. And if this is the centre of enlargement, then all the points are going to be 1/3 of the distance away from where they were to start with. So you can end up with a shape that looks a bit like this, kind of a smaller version of itself. B line on the centre of enlargement will be unmoved, so that is the invariant point. Invariant means it doesn't change. So circle the vertex that is invariant. That has got to be B. Now there are quite a few multiple choice questions in the exam, and even if you don't know what the answer is, you might be able to rule out one or two of the answers, and then you can just make sure you guess between them. Don't leave any of these unmarked. You've got a good chance of just guessing it right even if you don't know the answer. Okay, 26b, a sketch of the quadrilateral PQRS is shown. PQRS is reflected in the line y is equal to x. Circle the vertex that is invariant. Now let's just draw on the line of reflection. So it's going to go through the origin and it's going to go through that point 1, 1 then, isn't it? Because it's the diagonal y is equal to x. It's that line there. So if I draw that line on, I think you can see what will happen. So it's going to look a bit like that, isn't it? So anyway, the point that is not going to move is this point P that lies on the mirror line. So circle the vertex that is invariant. Again, that's going to be P. Question 7, we've got a question on function notation here. We're told that h of x, the function h of x is equal to the cube root of x for all values of x. On the grid, draw the graph of the inverse function h to the minus 1 of x for values of x between -2 and 2. Okay, now to find an inverse function, if we let y equal our original function and then rearrange for x and then replace the y's with the x, we can come up with the inverse function. So what's the opposite of cube rooting? I need to cube both sides, don't I, to get x by itself. So y cubed will be equal to x. So I can say that the inverse function h to the minus 1 of x is going to be x cubed. So I need to draw that function y equals h to the minus 1 of x between -2 and 2. So if we draw a quick table of values, so from -2, -1, 0, 1 and 2 for x, then h to the minus 1 of x is going to be the cube of those. So -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, 1 and then 8. Okay, so -2 -8 is down here. -2 -8. -1 goes with 1, 0, 0, 1, 1, 2, 8 up there. Okay. So now again we draw a nice smooth curve going through the center of each of our points. We're going to get that distinctive S shape of a cubic. Some cubics are a bit more turny in the middle, but when you've got no other coefficients like that, it's normally less pronounced like this one. Okay. And then 27b, for all values of x, f of x is equal to the sine of x and g of x is equal to x plus 90. On the grid, draw the graph of the composite function y equals f of g of x. So that means we need to take our function g of x and substitute that in where we see the x in f. So fg of x is going to be the sine of x plus 90. Oh, they haven't given us a nice sine curve to translate. Basically, this is going to be a translation of your sine curve, isn't it? Now, a normal sine curve starts at 0, 0. It goes up to 1 at 90, and then back down to 0 at 180, and then down to -1 at 270, and then back up to 1 at 360. So a normal sine curve looks like this. Now this is going to be a translation of the sine curve. Now what we're doing is we're replacing x with x plus 90. So this is a translation, isn't it? It's a translation of x. And it's 90 units to the left. Okay, it's always the opposite way as what you might think when you sub inside the function, rather than in the direction of x than in the direction of y. So basically we're going to take each of these points, we're going to translate it 90 units to the left. So this point here is going to be it now there at minus 90. That point that was at 90 is going to be at 0. That point is going to be here, and then here, and then here, and then we're going to have another one up there. So basically we're going to get something that looks like the cosine curve, aren't we? That's the graph that we're going to draw. Okay, good to sketch it out like that first, so we know what we're doing, so don't make a complete dog's breakfast of the graph paper we're given. So it's going to start here then, and then go through here, then through here, and then through here, and end up there. Okay, drawing our cosine curve in, or sine x plus 90. It's going to look like that. Kind of missed the point there. I think I'm going to redraw that one. Okay, that's a bit better. Oh yeah, and can't have a break in my curve. Okay, I'm happy with that. And that's the end of the paper. Well, I actually didn't think that paper was too bad compared to the practice papers. There was heaps and heaps of trigonometry in it. We had trigonometry in right angle triangles, and the sine rule, and the cosine rule, and also plotting a function of sine x plus 90. So lots and lots of trig. Loads of ratios in there as well, quite a few questions. The only one I thought that was particularly unusual or out of the ordinary was the one with the histogram. That one I thought was a bit unusual, perhaps a bit tricky, but I thought all the rest, if you were well revised and prepped for the exam, you would have had a reasonable chance of scoring highly in. Okay, that's it. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.